This video introduces the Evolutionary Stress Framework, or ESF, a complexity-based model that reframes autism through stress energy regulation and predictive processing. The authors of this work are Hogenkamp, an autistic researcher and lead author, Dhwani Sanghavi, a doctoral student focusing on education and practice, and Heini Natri, a biomedical genomics researcher focused on evolutionary biology and translational science. Existing models only capture parts of the picture. The medical model ignores context. The social model may underplay embodied challenges. The biopsychosocial model identifies important factors, but not how they co-regulate. Hybrid approaches often fragment the person. Current models lack a process-level account, explaining how biological, psychological, and social systems dynamically co-regulate. Energy regulation and predictive processing offer this common currency. This is vital, as autistic adults face significant disparities, including reduced life expectancy and chronic burnout. The Evolutionary Stress Framework, or ESF, reframes neurodevelopmental variation as the emergent outcome of stress energy regulation and predictive processing over time, which is referred to as adaptive calibration. Energy and prediction are a common currency. Allostasis means the brain achieves stability through continuous predictive adjustment. Predictive processing minimizes uncertainty under metabolic constraint, where prediction error is energetically expensive. Stress is the energetic work of maintaining coherence when predictions fail, linking biology, psychology, and society. Neurotypes emerge through adaptive calibration, where individuals develop stress systems tuned to their environment. Unpredictable environments lead to vigilance, while supportive ones encourage flexibility. Autistic traits reflect how a system learned to regulate uncertainty and conserve energy, not damage. Strengths and vulnerabilities are inseparable outputs of the same regulatory architecture. For example, sensory precision enables pattern detection but causes overwhelm. Monotropic attention allows deep focus but makes task switching costly. These cannot be separated. Pathology is reconceptualized as stress incoherence, a system state when calibrated systems meet overwhelming environments. Autistic burnout is allostatic overload from sustained mismatch. The ESF shifts the question from "what is wrong with this person?" to "how can we support sustainable calibration?" Development produces calibrated, not fixed, types. The same neurotype leads to different outcomes based on the environment. Health in this framework is an emergent property of fit, specifically sustainable regulatory coherence or allostasis. The ESF integrates existing autism theories. This includes enhanced perceptual functioning as an energy allocation strategy, monotropism as efficient deep learning, and the intense world theory as coherence maintenance under sensory load. It also addresses the double empathy problem as mutual prediction error. The implication is a shift from accommodation to co-regulation. The question becomes, how can this system support coherent regulation for diverse neurotypes? Co-regulation includes sensory predictability, communication flexibility, and distributing regulatory labor. For research, this means multi-level studies linking biological function and interoception. Clinical practice should reduce energetic mismatch and personalized support. Policy and systems need temporal flexibility, sensory design, and communication plurality for ecological inclusion. The goal is environments where neurotypes thrive. This framework is an open architecture, co-defined with autistic people, and focused on dynamic, lifespan-wide support. Health is emergent allostasis, or sustainable regulation, not the absence of symptoms. The ESF offers a unified paradigm for neurodiversity through adaptive calibration and energetic trade-offs. Health is an emergent process arising from the interplay of biology, environment, and experience. We must build systems worthy of the complexity they serve.